Okay, so some background. We're going to deal with some number problems as well as we're going to deal with some, like everything here we're dealing with max and min, right? What's the maximum or what's the minimum? That's the type of problem we're going to always solve, a word problem. So just some background. If I told you the sum of two numbers is 32, how would you write that? If x is one number and the second number in terms of x. So what's your first number? Our first number is x. Now instead of saying just x plus y is 32, how can I write the second number in terms of the first with the x variable? If they sum to 32, we know the first number is x. What's the second number? 32 minus x. Yeah. The second number would be 32 minus x. So being able to write things in terms of just one variable, that's what we want to be able to do, is write things in terms of one variable. Write an expression to represent the sum of the squares of two consecutive even numbers. Okay? When the smaller number is x. So first of all, what does consecutive mean? Things are consecutive. Yeah. One after the other, yeah. So for example, give me an example of two consecutive even numbers. 2, 4. Give me another two. 6, 8. Okay. Yeah, and so forth, right? Those are two consecutive even numbers. What do you notice the difference between the two of them? There's always there's a difference of 2. So it says when the smaller number is x, so the sum of two consecutive even numbers, if the smaller number is x, okay, the sum of the squares. Now the squares, what am I doing to these numbers then? Squaring them. So it would be x to the power of 2 plus sum is, we want to sum the two numbers. What would be the next number? If the first number is x and they're consecutive, what did you tell me was the relationship between these two? It would be close, x plus 2. So x plus 2 all squared. Yeah. So x squared and then x plus 2 squared. Okay. So that's just a little bit of background. So a lot of the problems we're going to deal with, or some of them, are going to be profit type problems. So you're finding the minimum cost or the maximum cost for something. Or it might be an area. You want to maximize area. So I guess usually cost you want to minimize. Usually your cost won't be a maximum, right? We want to minimize our cost for something if we're trying to build something. So there's a bunch of steps here, but we're just going to kind of jump into it. But this is one example. Two numbers have a difference of 10. The product is a minimum. What are the numbers? You always want to actually, like one of the most important steps is to identify what you're trying to maximize or minimize, because that's going to be your main equation. So in this problem, what are we maximizing or minimizing? The sum or the product? Or, sorry, difference or the product? The product, right? It says the product is a minimum. And so that's why we made an equation. So in this case, because we're actually going to minimize the product, we want an equation for a product of two numbers. What is product? What does it mean to make the product of two numbers? To multiply. And so we made an equation. Product is equal to the x times y. Okay, because we're going to start by making an equation with what we're trying to maximize or minimize. Now, like we talked about yesterday, what's the problem with this equation? That's what? Multiple variables, too many variables, right? We want product in terms of one variable, not product in terms of two variables. So we want to get rid of one of them. And that's why they always give you some other information. They go on and say the difference between the two numbers is 10. So we took the second number y, and so if we know their difference is 10, we could go the bigger minus 10 is equal to y. There's more than one way to write this equation. Here's one way. So that we can sub it into the equation. We can replace the variable of x. Okay? And then from there we can complete our square. We can expand it and complete our square. Why are we completing our square? Because we want the vertex. Because the vertex tells us the max or min value. Okay? So we're going to be going through these steps for each problem. Tough. Yeah. Toughest part is making this equation. Once you get here, it's not so bad. Especially if you know how to complete your square. So let's actually just jump into some problems. Okay, so it says that two numbers have a sum of 24, their product is a maximum. What are the numbers? So the first step is we want to identify what we're maximizing. We are maximizing what? Again, product. So our equation is going to be our product equals x times y. So that's our first step. Our next step is to eliminate one of those variables. So we need to write x and y in terms of each other. So they tell us that the two numbers have a sum of 24. How can you write that with x and y? X plus y is 24. Okay, but we want to eliminate one of these variables. Let's eliminate the y. So I want to get y by itself. That's what we're going to do. So how do I get y by itself? Subtract x. Get y is equal to, now we could either write this as 24 minus x, or else could we write it? Negative x plus 24. Yeah, I'm going to write it that way just because I'm going to make the, sooner or later you'll have to rearrange it so that the x is in the front. So if we do it now, we don't have to do it later. Okay, now what do? We did that so we could do what? Sub it in, replace the y variable. So our product is x times y, but instead of y, I'm going to put in negative x plus 24. Okay, next step. Yeah, distributive property. So we're going to get rid of the brackets here. X times negative x. Negative x squared plus 24x. So now once we have our equation in standard form, we want to turn it into a vertex form by completing the square. So we can see our maximum, right? Because that's what we're looking for. Okay, so completing the square. First step is factor out the a value. What's the a value that I have to factor out here? Negative 1. Good. So I factor out the negative 1, or just negative. I have x squared minus 24. If we divide both by negative 1, it switches the signs. Here, it's a little bigger there. Okay. Now, we take that negative 24, and what are we going to do to it? Divide it by 2, and then square it. So 24 divided by 2 is 12. 12 squared is 144. So we're going to add 144 and subtract 144. Who do we want to pull out of the brackets? Negative 144, the negative 1. Will it become a minus 44 outside the brackets? No, we have to multiply it by the negative 1. So what does it turn into? Positive. So negative 144 times negative 1 is a positive 144. And last, we write it in factored form. So factored form would be x minus what? 12, good. Squared plus 144. So our vertex is, what's our vertex? 12 and 144. Oh, a second. The machine is thinking. There it is. Okay. Vertex, 12 and 44. So you have to be able to interpret what each of these variables stood for. what did X stand for? What did it represent in this problem? The first number, okay? So 12 was one of the numbers, or the first number. What did the Y variable represent? Looking at our equation, what did Y stand for here? No, it's not the second number. What's the other variable that we have here in this equation? What's the other variable? The P is what variable? It's a product. Yeah. So you're graphing product, right? What we're actually graphing here is the one number and its the product. And so we're trying to find the maximum product. So this 144 is the maximum product. That's product. What's the product? So if I asked you what the maximum product was, you would say it was 144. If I want both numbers, that's where we have to go backwards a little bit. We know the first number is 12. How do we get the second number? 24 minus 12. So the second number was equal to, or the Y, 24 minus X. So 24 minus 12, which is also 12. So my two numbers are 12 and 12. Coincidence? Think not. We're 12 and 12. Okay? All right. So those are the number type problems. Those two. Let's talk about revenue. If you're trying to make money, simple economics. Very simple economics, okay? If you are trying to sell something, how do you calculate you're selling an item? How do you figure out how much money you bring in? Well, whenever we deal with revenue problems, our revenue is always going to be how much revenue we bring in, how much money we collect. It's always going to be how much it costs per item, right? Times what? The number of items. Would you agree with that? If I'm selling, I don't know, maybe I like to make toques. I'm Canadian. I knit toques. Okay, if I sell 20 toques and I sell them for 10 bucks each, how much did I make? $200, right? Our revenue we're going to always bring in. So all revenue problems, we're going to set it up as the price, the number of items we sell times the price per item, essentially. And so these problems are what we're going to do with them to figure out is they're going to change the price. And we want to figure out if we change the price, what should we change the price to so we actually bring in the maximum revenue? So it's a simple economics type question. Karina makes and sells holiday wreaths. Because everybody loves holiday wreaths, right? I don't know. Last year she sold 45 wreaths and at $18 per wreath. So how much revenue did she take home last year? 45 times 18. So that gives you your... She did pretty well, just for wreaths. 810, was it? Yeah. Good for her. But she wants to make more money. Can't blame her. She knows from experience that for every $2 she decreases the price, will result in the sale of 15 additional wreaths. Ooh. She likes going to those craft sales. How much does she charge per wreath to maximize her revenue? So we're always trying to maximize in a revenue problem. Obviously, we want to bring more money home. That's what we're trying to maximize. And so that's why our equation is going to be revenue equals. Now, the other part of the question is how much should she charge per wreath? Okay? So how we're going to set this up is we're going to let X be, let's write this in green because it's St. Patrick's Day. Yeah, let X be the number of $2 increases. Okay, so you're always going to let X be the number of increases or decreases. So the number of $2 decreases. So if X was 1, then you decreased it just by $2. If X was 2, You decreased it by how much? $4. If X was 3, you decreased it by $6. Okay, so X will always be the number of increases or decreases in the given context. Okay, so now let's figure out our revenue equation. So before, what was her price per wreath? $18, right. So she charged $18 before, but her new price is going to be 18 minus what? 2x. How many? $2 right? $2 times the number of decreases. Good. How many items is she going to sell? Well, for every X or $2 decrease, how many more wreaths does she sell? 15. So how much is she expected to start at? Last year she did 45. So her number of wreaths she expects to sell this year, for every $2 decrease, she's going to add 15 X's, because it's the number of $2 decreases. Not so bad? No. Once you got that, we're going to FOIL, complete the square. So let's FOIL this out first. All right, 18 times 45. This is where our calculator's handy. I'm sure not many of you have that memorized. Maybe you could do it in your head. 18 times 20 and then minus 90. Do some mental math. Oh man. I'm gonna make it through this lesson, I swear. Okay, 18 times 45 was 810. Oh, we knew that. We did that already. Silly. 1810. 18 times 15. I don't know today. 270 X? Yeah, it totally is 810. Thank you. Thank you so much. Yeah. Okay, negative 2 times 45 is negative 90x. And last, negative 2 times 15, negative 2x times 15x. Negative 30x squared. We want to rearrange our equation so it's in the right form. So that means that x squared has to go first. Collect our like terms, which makes 210. No, it doesn't. Sorry. 180, right? X, we subtract 90. And plus 810. So now we want to complete our square. So how do we complete the square? First step, factor out what? Negative 30 from who? The x squared add the 180. What is 180 divided by negative 30? Negative 6. Negative 6x. You might want to leave your space right now. We can kind of add in. Blow my nose. So, revenue equals x squared minus 6x plus 9. Negative 9 times negative 30 is plus 270 plus 810. And so you should have had x minus 3 squared plus, I could do this, 1080. Okay, so what's our vertex? Vertex is 3 and 1080. Okay, what did the x variable stand for? The number of $2 decreases. So we decreased the number of $2 decreases. And what did 1080 represent? The maximum profit or the max revenue. Because our equation was x versus revenue, right? We are relating revenue and the number of decreases. So when it asks you, this is where we made those equations right off the bat. So when I'm talking about those equations, I'm talking about, let's use magic pen. My magic pen, there it is. Okay, so when we're looking at this equation here, remember that represented the number, that was our price, right? 18 minus 2x. And then the 45 plus the 15x was the actual how many wreaths we actually sold. So when it asks me how many wreaths will she sell and at how much money will she earn if she sells it at this price? So first off, how many wreaths will she sell? How do we figure out how many wreaths she'll sell? Would I use the 18 minus 2x or the 45 plus 15x? 45 plus 15x. And what's our x value? 3. So the number of wreaths she actually will sell is equal to 45 plus 15 times 3. Or, how many? 90 wreaths. How much money will she earn at this price? Do we know what that is? Do we know what her revenue is? What is her revenue, max revenue?
1,000.
Yeah, and so then for running in a room, a max revenue of 1,080. Big improvement from her 810 bucks she made last year. She made 270 more. Nice. Mama's getting new shoes. Okay. Revenue, fun. So I'd like you to try and set up the next problem. Same idea. A theater company charges $12 a ticket. At this price, 450 people attend. They estimate that for every $2 increase in price, they'll get 25 fewer people. What is the maximum revenue? So I want you to figure out is make your revenue equation. Try and make the revenue equation. So price per ticket times the number of people. That's your revenue, right? What is x going to be? Just what does x stand for? What does x mean? What are we letting x be? The number of what? $2 increases. Okay, defining our variable is very helpful, especially when we go back at the end, you do all this work and you lose sight of what you're actually looking for. Oh yeah, x stood for this, and right? Okay, so what's your price per ticket going to be? Your new price per ticket? 12 plus 2x, good. Plus 2 times the number of $2 increases. What's going to be the number of tickets sold? 450. And you're going to get 25 fewer, so that's minus 25x. Good. Okay, I'd like you to FOIL that out. You can do it. You know how. Okay, did you get something similar? Yeah?
Yep.
Where do we go from here? Yeah, complete the square. So take the negative 50 out. X squared, what's inside our brackets? Minus 12x. How do you get that? You divide 600. We're factoring out negative 50, so we're dividing each of those by negative 50. So minus 12x. I'm going to go and leave my space now to save room. Okay, what are we adding and subtracting? 36, good. 12 divided by 2 is 6. 6 squared is 36. So we have to move the negative 36 out. We have negative 50, x squared, minus 12x plus 36. What is negative 50 times negative 36? 1,800, thank you. And last, let's write it in factored form and collect like terms. So we get x, what? Minus 6, good, squared, plus 72. So what did this question ask us? What are we actually looking for here? Max revenue. So what's the max revenue? Okay. So how I could do this on a test so that you don't just solve it graphically is I would ask you to actually solve algebraically, find the max revenue algebraically by completing the square. That would be a written response question. So if you just solved it graphically with your graphic calculator, you would not get full credit. You'd hardly get any credit. Okay, so you have to be able to do this algebraically. It's expected of you for Math 20. Okay, one more I think, and then maybe we'll... Yeah. I don't know if we'll do 5. I'll think about it. A rectangular playground is bounded on, like these, we've already done a million of these, hey? So where you have a rectangle, and one side is the wall, and then you have 60 meters of fencing. Like, clearly, that should not be a straight line, first of all. Let's try that again. Like, clearly you're going to have a question like this on your test. You see them, like, over and over and over again, right? Maybe it'll be, like, more than one width, or more than 2 widths. Maybe there'll be, like, 2 equal pens type of idea, but that idea, this, like, area problem is pretty popular. So it says determine the dimensions of the largest possible playground. So what does that mean? What are we trying to maximize or minimize? We're maximizing area. That means to maximize area. And so area is the equation that we want to make. Whatever we're trying to maximize or minimize, that's our equation. So what's the equation for area? Length times width. But then we say, uh-oh, there's a problem. Problem is, yeah, 2 variables. So how do we get rid of the one of the variables? What else do they tell us? 60 meters of fencing. So that means 2 widths plus 1 length equals 60. It's easiest to rearrange for who? The length. So subtract the 2w to the other side. You can write it as negative 2w plus 60. I'm going to do this time to show you how we still have to rearrange it. So if I wrote it as 60 minus 2w, it doesn't really change it. And so now we can replace our length with 60 minus 2w. So length times width. I'm replacing my length with what length equals. Okay, so again, we FOIL this, I expand it. So I get 60w minus 2w squared. Before I complete the square, is there anything wrong with that? Yeah, the w squared has to be first, right? So we have to move the negative 2w squared in front. So this is where I'm talking about rearranging. So if we wrote it as negative 2w plus 60 earlier on, then it kind of solves that problem early. It doesn't matter. Okay, completing the square, factor out what? Negative 2, we're left with w squared and plus 60, negative 30w, because we have to factor out negative 2 from that. All right, this is a fun one. Negative 30 divided by 2 is what? 15. What's 15 squared? 225. So when we bring out negative 225, what does it become? plus, because we're multiplying it by -2, plus 5, oh, no, 450. Plus 450. All right, so what were they asking for us to find? The dimensions. Are the dimensions 15 by 450? No. What did the 450 represent? Yeah, the what? Maximum area. The maximum area is 450 because we're comparing width with area. So if our dimensions are, our width is 15, what's my length? How would I get the length? Yeah, 60 minus 2w. So 60 minus 2 times 15 is 30. So it's 15 meters by 30 meters is our answer. Okay, number 5, the last one is very similar to ones we've looked at before, where we had to make the equation. Let's just try, I'll just like set it up. Maybe I'll do it quickly. Let's just do it really quickly and then we're done. It's one of those tunnels again. Okay, it tells you that the maximum height of the tunnel is 9 meters. It's these ones. Okay, and that the width of the base is 12. So these problems, we had to start by like setting up our axes, a y and x axis, because there wasn't here. I'm going to put mine at the edge this time. So y and x. So we have the point 0, 0. We have the point 12 and 0. What's the vertex going to be? 6 and 9. Good. So we start by making our equation in vertex form. So before we can answer the question, what is the maximum clearance at a distance 1 meter from the edge? So 1 meter over, how much clearance do I have? What's the y value? I need to know the equation before I can answer that, right? So we need to make the equation. And because we know the vertex, we're going to use vertex form. Oh, it's always where we start, actually. We always start with vertex form. Do we know A? Do we know A? No. Do we know P? What's P? 6. So x minus 6 squared plus 9. Good. How do we find A? Sub in? Remember doing this? A point. What's the easiest point? Yeah, let's do 0, 0. 0 equals A times 0 minus 6 squared plus 9. So we have to subtract 9 over to the other side. I'm doing this question fast, I know, but we've done these before. Negative 9 equals 6 squared is 36, so 36a, and then divide both sides by 36. Okay, and that can reduce to negative 1/4. Okay, so we know our equation. We can replace our a, and then our vertex is 6 and 9. So now you can answer a question. I could ask you, one fun question I might ask is like the width of the tunnel from one, like maybe I could ask you like this width here. I didn't, but I could. If I wanted to know that width there, at a specific height, I'd have to find the x values for that, right? I could graph it, go y2 equals. So if I know like this is at a height of like say 7 meters, you could graph your equation, go y2 equals 7, find the two x values, and then subtract them if I wanted that width. I can ask a lot of really cool questions now. Now this graph is only asking how high or what clearance do I have 1 meters in. So what's my x value? 1. We can just sub in 1 and get our y value. Nothing fancy. Just how high do I have at 1 meter from the edge? And that's why I use my vertex as 0, 0, because it's a nice answer. It answers the question nicely. Negative 1/4, 1 minus 6 squared, plus 9. Okay, 2.75 meters is the clearance. Have you heard about like all the trucks getting stuck under the high-level bridge lately? No? Happens all the time, but it's been happening a lot lately, I guess. The high level on, 109th Street. There's not, like, big trucks always get stuck because they don't read the clearance that they have, and yeah. So we've had a couple 2 days in a row, like, just stuck under the bridge. It's funny. But not funny, but funny. Okay, so we're done. This is all I wanted to get through. So you have a handout. You should have a handout for max and min problems. I put the solutions, the worked out solutions, on the math website. So I'm going to show you that. So if you go to the math website, you can see if you're working at home max and min problems. There's a handout. If you click on that, and you can scroll down, there's the worked out solutions for each one of them, okay? So they're there if you get stuck. So that's your assignment for today is from the handout. Just gonna write that down. So yeah, and from textbook. Well, you have today and tomorrow. Okay? So this is all that's assigned. So you have today and tomorrow to work on this. You have tomorrow's class as well. So numbers 192 to 197. See, 13 to 15. These take practice. The more you do, the better you'll get. And then no matter what you approach on your test, you'll be okay. And then once you finish those, to review for your quiz is Monday. You can work through, so don't feel overwhelmed because you also have a full block tomorrow to work on stuff. Okay? Lots of time. Maybe. Okay? I'll leave that up for you.